Thank you. Thank you very much. So, yeah, my name is Martin Meyer. I'm one of the creative specialists at the Foundry.
We encourage you to watch and play with this Getting Started project video to learn some of them.
There's another guy.
It's another guy taking over. Yeah, so today we'll be talking about, or I would like to show you the latest and greatest goodies inside of NUKE, and NUKE 10 more specifically. And then KATANA, sort of a different type of overview of KATANA. And we'll actually get to open it and see it, and we'll see how it operates. But before all of that, I would like to sort of raise the roof for all the great work that our clients were doing with our tools. And let me show you our 2016 demo reel. Yay! Yeah, lots of cool magic there. So let's have a look at NUKE 10 and the goodies in it. So I'll just open up this little boring bit, and let me show you. This is sort of an overview of everything that we have in there. So we focused on the studio side, we focused on the timeline performance, and we were trying to make it faster, more stable, to be able to handle bigger, more extensive projects with a lot of shots. We are also working on the real-time playback, so on a specified hardware or certified hardware, it should run up to 4K with several streams, stable, all stable, of course, if you have fast hard drives to support that. We also have quite a few nodes. There is more and more nodes receiving GPU acceleration. One of them is the new vector blur. Also, we have the integration of ACES and Open Color I/O for the color management. We now support multi-GPUs on the AMD cards. Transcoding, especially to the quick times and ProRes is much faster than it used to be. Rotopaint, This is something people were asking, so it's again faster and better. So the new features really is the new additional tools are the refined editorial and conform tools. We'll look at the Blink script and the integration of the Blink script to the timeline, which is one of the biggest additions on the studio side of things, on the timeline side of things. Then we also integrated new effects as a color correction and Blink script and keying. All of that is happening in real time. We'll have a look at that during the demo portion. And we have a new localization or the revamped localization system for both NUKE and NUKE Studio. So it's all unified and it works all together nicely. Through ray trace render, this was mostly integrated for to enhance the VR and stitching and essentially rendering workflow that supports reflections, and it can render ambient occlusion and other additional passes if you need them in the compositing stage. And probably one of the coolest things that was added to the 10 series is the whole smart vector painting or vector generation and painting stuff. So without further ado, let's have a look at the way things operate. So I'll just go ahead and launch NUKE Studio. And let's open up a project and we can explore. So what you see in front of you is the interface of NUKE Studio. It's our editorial tool, the editorial part of NUKE. It's really a NUKE's timeline. So the main problem with this project is that the media is not matched. So I'll just quickly go to my conforming, and let's say I receive this from editorial department. I'll just hit match media, point to the folder where all the footage resides, where it's actually all sitting, and I just can hit next or open, and Studio will give me a pattern that it will search for within the folder, and if I hit OK, it will happily go through, reconnect my clips, and I'm happy to start doing my VFX work. So on the timeline, we have a couple new updates. Mainly, it's the playback performance. I'm currently working from this little toy laptop, and it has a one single SSD. These are 2K streams in there, and it plays flawlessly. I can go back and forth very easily. Now, if this was a situation that the media actually resides on the network, somewhere where you will be competing for the bandwidth with other artists, you can very easily help it thanks to the localization that was exposed right now. It's not hidden. For those of you who were using localization inside of NUKE, now it's all right in your face. You can really quickly access it. If you have no idea what localization is, it just takes the media from your file server, saves it to the fastest drive, and the data has really no value. It can be erased at any point, and NUKE will relocalize. So you're not competing for bandwidth, and you can use off-the-shelf hardware that to speed things up. We can localize practically everything. We can localize the whole sequences. We can localize the actual clips. So a lot of control to help you with the performance, especially in a pipeline. The other thing, aside from the speed improvements and the localization, is the addition of a few new soft effects. So for example, we have now, if I just go here and add for example, the chroma keyer, we can now do certain things that were not previously possible in the timeline. So for example, I can just quickly go here and key right here. And this is all happening on GPU, and it's running in real time. So it's great for doing slab combs on the set. And if I actually go ahead and enable my track blend, it will put it on top of the underlying track. There is another track with a green screen, but all of this will be then transferred to the NUKE script, but it's really fast and really responsive. Another really cool thing about this whole system is that now we actually enabled Blink script, which wasn't previously possible on the timeline as well. Blink script is a GPU-accelerated scripting language for development of plugins. So that opens up the door for all third-party developers to actually develop something for the timeline, like Baselite and other people are already taking advantage of that. Or within your facilities, you can develop something that actually will run specifically for you, and it will be GPU accelerated, so it can really help. So that's I guess one of the most exciting things on the timeline itself. So now let's actually open up NUKE itself, or NUKE X, And let's have a look at some of the additional stuff that was added to NUKE. Let's give it a moment to open, and I go here and let's have a look at the, for example, this one. So throughout this whole process, we are constantly trying to enhance NUKE and add features that actually solve specific workflow issues. And one of the more exciting ones, or probably the most exciting one in the NUKE 10, is the Smart Paint toolset. This allows you to generate vectors, motion vectors from existing footage, and add or remove certain pieces of the footage based on those vectors. So this is a fairly typical example. Here I have a typical problem, few tracking markers on the face, and I would like to remove them as efficiently as possible. So the whole process starts by essentially arrive from this to something like this, with the minimal work involved. So traditionally, you would probably paint them out, track them out throughout the frames, but the motion vectors allow you to do much more and much more quickly. So the whole process starts with this little smart vector node. There are really no settings aside from the quality or the vector detail. So once you select the node, you can render this out in advance to EXRs or any kind of format that supports 32-bit. I would recommend you to use EXRs. The vectors need to be generated in advance because they take some time. It's nothing serious, it's just they take a few minutes to process for existing footage. And then the whole fun starts. So I went ahead and painted the trackers out on frame 5. And one frame only. There is no need to paint anything else. So as you can see, this lives only for one frame, and just a bunch of clone strokes to paint everything away, like so. Once that was done, I just went ahead and added some alpha erode to blur the alpha a little bit. So if I disable that, I'm just softening it up so it blends better with the existing footage. And the majority of the work is actually done in the Smart Vector node. So if I look at the result, this Smart Distort takes my reference frame 5, which is the one that I painted, and it will interpolate it based on the motion vectors that were pre-rendered. So the vectors look actually pretty cool. Let me just show you how they operate, or how they look. It's a really funky AOV to have. It'd be good for some rave party invitation thing or something. So, but aside from that, we can pipe them into the Smart Distort stuff. And what happens when I actually process this? This will go through and smear the pixels of that one single image through the motion vectors. So what you see right now is not really moving, well, it is moving, but not really a moving footage. It's just the pixels of frame 5 distorted by the vectors on frame per frame basis. The good thing is that not only the colors was smeared, also my alpha, which actually I need to pre-multiply, so I'll just go back and pre-mult it. Also my alpha was taken for a ride, so they are moving now happily together. So to finish this trick, all you need to do is just place the alpha on top of, or the rendered little dots on top of the footage, and you get a clean plate, or clean render. So it really works extremely well, and it's really fast to use. The whole process took, well, to paint these few frames, it really took less than an hour to just quickly get rid of it. So really powerful tool. Obviously, it doesn't only have to be used for removing of things. I have a little example here that you can use this sort of as a tracking tool as well. So just open this little movie app. And the process here is very similar. We are tracking, are creating the vectors from this particular footage. They're created in advance, and then we can use that to move certain pixels around on the screen. And then when you actually add some detail to this, notice the little wrinkles and everything that gets picked up by the vectors. So the cloth actually influences perfectly whatever the addition is. So adding scars and little whatever things on the textures and numbers on t-shirts and removing that gets really easy with this. Really, really powerful thing. And additional sort of added, if this actually starts to fail, which, you know, obviously it's a smearing of the pixels on the screen, you can always just create multiple clean plates and then merge them together to create a clean plate from any footage. So this is another example. Here I have, I'll just look at the input. Here I have a lady walking through the screen. She turns, and the idea here was to remove her tattoo from her back. The paint job is not the best. I'll just make it a little bigger. The paint job is not the best, but the tattoo was successfully removed. And that was really accomplished by tracking multiple frames from frame 111, 87, and 44. So 3 frames and just blend it together. Again, minimum hand or minimum work involved. And I guess the last thing that I want to show you, which is a little trippy, is that you can also use the smart vectors to stabilize things and paint them out in a slightly different way without actually dealing with the perspective. So here I have a footage that creates an ST map or distortion map from my plate. So effectively, it strips the motion away, which can be distorted back again to the original state. So now I get the back completely exposed, and this makes the painting out of the tattoo, I guess, much easier, because then you can distort it back with by reversing this process. And it looks like, again, something from a music video thing. So smart vectors are really, or smart vector toolset, really powerful stuff inside of NUKE 10. And it's all based on our Ocula technology. So the optical flow and computer vision-based algorithms are used throughout. And the last thing that I would like to show you is this little handy ray tracer that is currently inside of beta now. It's not a properly full-featured ray tracer that allows you to do magic like V-Ray can, but this can be a really nice helper to add certain elements like a reflection on the water or other interesting bits and pieces, proper ray trace reflection on the water of your cards inside of NUKE, for example. So this right now is actually tracing reflections from a set of spherical environments, and I can very quickly change the environment using the switch node, and it will be ray traced directly inside of the NUKE. It can, since it is a ray tracer, it can also do ray trace shadows. No global illumination and any of that, but it can do ray trace shadows. So, for example, here I have another pass that you will be familiar with. This actually generates ambient occlusion. But all in all, even if you're just using it as a counterpart of the scanline renderer, it is still way more memory efficient, and it allows you to handle certain things that the scanline wouldn't be able to handle. For example, the pinching on a spherical stitches on the poles. Good. So these are the enhancements inside of NUKE, the current release of NUKE. There are, well, more stuff coming, but this is a general overview of that. So now let's maybe a few minutes for questions. Any questions about NUKE in general right now? Before we move to something else. Yes? The file is localized. It's all about the inputs, really. So you localize, the files get saved to your local drive, and but the path is still pointing to the file server. So NUKE knows that it has the local copy, it will use it because it's faster, but the direction, the link is still to the file server. So when the project is done, you just delete the stuff from the file server and from the local drive, not the file server, no, from the local drive, and it's still linked to the file server. If the file changes, NUKE is smart enough to realize that, hey, this is a new version with the new dates and will relocalize the stuff if the localization policy is enabled. So yeah, the local data really shouldn't have any value. That's there just to speed up things. You actually render and load from the file server for all the purposes, the whole file appears to be linked to the file server. That's very good. That's awesome, awesome. Good. So now, Katana. Let's do that. Let's have a look at Katana. Everybody run. Yeah. Let's close all this. And this. And this. And let's have a look at a little presentation. So, Katana, the Worldwide Effects guys did an amazing job presenting Katana, so we'll just have a look at the slightly different, we'll quickly reiterate, and then we'll actually have a look at the tool. So, it's our look development and lighting tool. By look development, we really mean going from something that's just an asset in the pipeline, like a mesh, geometry of some sorts, cache, through the texturing process to the final look, to the actual deliverable looking project or product. And then also creative lighting. What we mean by the creative lighting, by actually developing the lighting for sequences, short sequences, and then the whole movies, and managing the way the color and the look and the lighting flows through the whole project. So in this case, this is just a bunch of color boards from multiple projects out there. Katana generally lives in the look dev and lighting department, so everything that you create in the pipeline from the models to the textures to, well, practically everything that's made, all the caches, including the volumes and VDBs, flows to the Katana, gets lit and rendered eventually and composited. So generally, Katana solves a couple issues, or it's aimed to solve several issues. One of the biggest ones, for me, was the loading of the scenes. Since everything is external to the script and nothing is shown at any point until you actually really need to see it, the scripts or the scenes load up extremely quickly, regardless of how much geometry you have in there. Because it doesn't really need to show you anything, it doesn't need to process anything until the renderer asks for it or you ask for it. It also allows you to collaborate between multiple artists, lighting artists, where you can share the look files and you can share individual bits and pieces of the script, and they all funnel into one final render script that can be distributed to the render farm. Also, the collaboration with different teams, since everything is external. The geometries, the caches, the volumes, particle simulations, any kind of stuff, it's all external. The teams, Katana is like the master referencing system that connects it all together, and it allows you to ship the data to the renderer for the final output. You can actually have a whole sequence inside of one script. Depending on the way people work, this can really simplify your life tremendously, because you can actually get to see the continuity from one shot to another. But again, it doesn't restrict to that. You can set it up the way you like it inside of the pipeline. The restrictive and complex archive-based pipelines really refers to the traditional, old-fashioned way of working, where you would write some sort of caches, either as RIP caches, anything that needs to pre-process the geometry to move to the secondary step. The Katana renderer lives inside of, or Katana node lives inside of the renderer, and it feeds the render node or the render engine with data on demand. So you don't need to pre-process anything. It literally, the renderer gets whatever it needs from Katana node on fly, and that can save a lot of disk space and a lot of pre-processing initially. And that kind of also goes to the point 6, where the not fitting in the memory is solved because the renderer only gets what it needs at any point to render those pixels. It really helps to streamline the whole process. Since nothing is really referenced, you're just making overrides. Those overrides are very easily removed or added. You're really just fixing and molding the scene to whatever you need it to be. And again, since everything is external, any kind of change of the animation will just go through. So if the animators will create new caches, Katana will pick it up, it will apply the lighting and ship it to the renderer for the final pixels generation. So, oops, why did I do this? Let's just quickly go here. So this is really simplified version of the traditional Katana workflow. You create the objects, your assets in some digital content creation app, like Maya Max, Modo, Houdini, whatever else is out there. Anything that can essentially save Alembic will do, or you can develop your own file format. And then we ship it through Alembic, and currently we are working with Pixar to develop the USD, which I think will be a great thing, because that might simplify the whole data flow from application to another. All of that gets compiled for the renderer. We currently support V-Ray, 3D Daylight, Arnold, and with more renderers like Redshift are still coming on board. And then all of that gets shipped to the render file management tool of your choice. Currently we work with Cube and Deadline. And all of it goes to NUKE, and off we go to the projection screen. So there is a various, these are the renderman, these are the rendering engine that we currently support with the various level of support. Chaos Group has a really nice way of transferring materials between Katana and Maya, for example. 3D Daylight can transfer whole scenes. Solid angle renders really nice volumes. It depends, but the level of support throughout the rendering engines is really growing, and it's becoming more and more streamlined as we work with the third parties to add new features to hold this. On the rendering solution, we have Deadline and Pipeline Effects, or Cube, in beta. But the Deadline is really supported fully, so you can even it can figure out things like job dependencies and many really advanced features of the whole rendering system. So by really Katana, I guess, kind of comes down to money, because you can automate big chunks of the shot production, and computers can, in theory, work 24/7. So you can really save yourself some time. And if you don't save some time, you can at least produce you can produce better art, because you're not spending time in areas that don't really necessarily matter. How it actually does it? So here I have a short movie. Let's watch that.
Finds our antics to be somewhat disconcerting.
Oh, really?
Yes. So I think in the interest of saving our show, David,
we need to
bring it down. And so, this week on Modcast, we'll be talking about 701 sneak peeks.
Yes. Let us discuss recently the Modo 701 sneak videos that we've been posting on our YouTube playlist.
David, I gotta tell you,
and in direct comment,
I'm very excited about the videos we've been posting.
I think the videos elaborate on our ideals as a company and what we like to project to our user base.
Yes, I hope I can convey my excitement to the community about these videos.
Whoa, Brad. Tone it.
I need to bring it down. I apologize.
So
I can't do this anymore.
It's like you cannot cage the beast.
No.
Okay, so this officially won the award for the silliest video that was produced by these two guys ever. So we decided to use it here. But if you break this down, actually, hello. If you break this down from like a shot management point of view, you get something like this. There is our lighting point of view. There would be normally one master shot that defines the lighting of the sequence. That dictates how the rest of them will kind of look. And then, of course, you need to do the per shot overrides. So those are the orange ones. The orange ones are tweaks. They tweak the look You have a rim light, just adding, adjusting things, improving them. And the green ones are in the good area. They should theoretically be generated for free or with the minimal interaction, additional interaction by humans, because the structure kind of defines how the whole thing should happen. And so we have 21 shots in the sequence, in this particular sequence, and in this case, this is the breakdown in terms of work. You can theoretically get 62% of this with a minimal effort. So enough with PowerPoints. Let's launch Katana and let's have a look at this actually works. So I'll just open up the tool and so first thing first, let's just set up my path. So I'll just redirect everything to my project directory. This is really handy way, but with a little script you can really quickly change what you're working on. And let's open up some script. So here I have a simple example. So as the Worldwide FX guys showed you, Katana is a nodal processing system that allows you to bring in various pieces and then build some incredible level of complexity by combining them. So in this case, let's open up the viewer. In this case, this scene has roughly 700 million polygons of instance and not instance geometry. This is a very simple laptop. And let's have a look at the way this is assembled. So if I open up my world, there is currently these three subdirectories. There is the cam, geo, and light. So my cameras are coming in, my geometry is coming in, and the lights are coming in, and everything is external to the scene. One thing that you may have noticed at the beginning, when I opened this, it really took no time. It was like a second, right? It just opened up. It was there. Because it's not showing me anything yet. So if I click on the city only, you see that the path or the structure really changed to something else because I'm actually looking only on that node and there is nothing else visible. So inside of that node I have a geo, city, and slowly I'm digging inside of that structure that came in or was loaded in from the Alembic export. If I open up the houses, it will show me something. Hey, yeah, here I have a first bounding box of that structure. But that's not enough. Well, maybe I need to, this might be good enough for general position of the sun, lighting with the general position of the sun. But let's say I would like to work on something even deeper. So when I open this up, it will start bringing in more of the geometry and will start populating the world a little more. So now I see a little deeper into the world, and it's not over-stressing my system. I really need to see only what I need to see. So when I double-click this, it will take me to this house. You can select stuff inside of that, and it took me to the lowest level of this particular asset. So in this general philosophy, you could have a whole city that is represented just by simple bounding boxes and go down to the screw on the window in the building 5620 in the back. And it will still allow you to get there because it will really just show you whatever you need to see at at any point. I refuse. Good. So that allows you to manage the scene complexity, the fact that everything is deferred and not forced on you or nothing needs to be processed. So city came in happily. Next thing we need to bring in my foliage, which this is the trees. Then I have the ground. And in a very similar way to a compositing package, if I click the merge, voila, all three things are currently in the world together. So they got merged, and you can also pass them to a different paths and different structure. You can structure the scene any way you like it. This is actually a really handy node. This is taking the shaders, and it's applying the shaders based on collection language, as the guys showcased. So it searches, for example, this one is just searching for everything that's named house 3. There is several house 3s, and it will apply a specific shader to that. In the next node, we actually get to the cameras enter the scene. So, well, the camera that's named shot cam. And then all of this gets processed down to the render node at the end. So if I just enable the live render, and I will feng shui the user interface a little bit here. And let's give this little box time to warm up. It will kick in a second. As the data is flowing, it will, voila, at the end, it will appear all assembled there. So we have lots of instances of the trees, and there is lots of buildings, and there is this type of trees, and ground, and other things. If you're digging through the render, through the scene, and you want to adjust shaders or adjust the object or select the object, we have also this little handy tool that allows you to, just a second, sample what is actually under that pixel. So not only I get the color values, but I also get the object. So let's say I would like to select the column on this guy. I can just go here and then say select from scene graph. It will find it here, and in the viewer, I can just go into it. So it's not only about digging through complex structures, but here I have that particular asset visible, and I can do things to it. Another really interesting aspect of Katana is the fact that you can have scene state or scene graph, graph state variables. And these are variables that can trigger different states of the graph based on, let's say, in this case, shot. So this particular scene manages 3 shots. It manages shots 10, 20, and 30. So if I change this, you see that the camera changed and the lighting changed. If I go to shot 30, it will change the camera and change the lighting. How this is done, we're actually using the switch node that is looking for changes in the scene state variable, and it feeds the whole script, either camera 10, 20, or 30. This can be done through asset management software. This can be done in many ways, but essentially the renderer gets fed a different camera based on your properties. So when you're submitting this to a render farm, you literally have the same script, just submitted 3 times with different scene state variable. It's the same scene, you manage one scene only, no additional data created, no mess, it's all clean, gets shipped to the farm, and it gets rendered. All you have to trigger is some property of the whole graph. Another thing that's happening is, or where I'm using the variable switch, is here, where I have 3 lighting scenarios. There is this one, there is the one where I'm adding a spotlight for shot 20, and then I'm adding different properties of the spotlight for shot 30. And the switch dictates what lights in what combination will be used. So if you look at the scene, the way it's actually assembled, I'll just close this together. Here I have my lights. If I change this to shot 10, which has only 2 lights, the one light will be gone. It's not there in that particular shot because it was never fed to the renderer. It goes through here to the renderer down to the outputs. Which can be really, really powerful if you're building some complexity. Another interesting things are the live groups, which this is a live group. The lighting was actually established in an external scene, and this is being loaded from completely external source. So the supervisor, somebody really created this basic setup. And you can always go ahead and edit the contents, enable the editing, and then you can change the properties of this. You can then remove this if you want to, because there is, of course, a better way, which is through the additional gaffer nodes. So these sky and sun are created and loaded into the scene. But here in this node, I'm actually bringing them in, and I can say adapt for editing, and that will allow me to change the property of that light. And only that, it's an override, right? So the light comes in, gets processed, gets shipped to the renderer. If you don't like it, or you need to create a different version, you can just delete the edit package, and it will revert back to the state that it was loaded into. And if you need to create additional shots, you can just copy paste this, reconnect the stuff, and you will have lighting for another shot and just add another variable. A very, very clean workflow, I think Katana allows you to achieve. So this is a really brief overview of the tool. Any questions at this point?
What file format is used for lighting?
In what sense? The inputs can be mostly Alembic, or it will be USD for the scene structures. The outputs can be really whatever you are rendering into. EXRs, DBXs, whatever you need.
I was asking how could you connect VRAY light to it?
The lights, it depends on the renderer, but for example, if you want to create a new light, I'll just go to this guy, and let's look at the viewer. I'll open up the geometry a little bit. And just close this, and open up the houses, only up to the level that I need to really see them at. So that is something that's enough. And then I can, maybe I create a new light, call it something, whatever. Then I can essentially add, I can choose what kind of light it will be. Let's just do that. It's now, for some reason, acting up, but you can essentially add the type of light, and once you have the type of light added, you can just look through it here, for example, the spotlight, and now I'm looking through the spotlight and I can start lighting with it, moving this around. But I don't think that's what you were asking. I just don't... well, we can talk outside, yeah? Cool. Well, thank you for your time. This is me.
All right. Thank you.